This is a PCB etching machine. It fits into a handy case, which can also be used as an etching tank. The device moves the PCB back and forth in the etching solution, making the process faster. After 30 minutes, the device stops automatically and makes a sound. The system is controlled by a microcontroller. I first tested my idea with this simple setup. I checked if the small servo motor could move a wooden block. I wanted to see if the servo was strong enough and if this kind of lever system would work. The servo is controlled by an Arduino Nano Supermini. Since the idea seemed to work, I designed a case and 3D printed it. The idea is simple, but making mechanics was challenging. The parts needed to be precise, but not too precise, as they must move easily without friction. Otherwise, the small servo I used wouldn't have enough power to move them. This sliding part needs to be in the right position. The small notch fits into a slot and moves the entire upper section. The servo is connected to the sliding part with a wire and lever arm. At least these parts are working well, and the servo can move the top part easily. At least without load, it seems to work very well. Let's start connecting the electric components. This LED will be an indicator, and it needs a resistor. The device also needs a big capacitor. Without it, the servo stops working after a few minutes. The capacitor keeps the voltage stable, and this servo is particularly sensitive for voltage fluctuations. Next, I connect some wires and attach the microcontroller to the case using double-sided tape. I really like the Arduino Nano Supermini for two reasons. First, it has no components on the back, so it is easy to attach with double-sided tape. Second, the USB-C connector works as power input of the device. This makes assembly easier, as I only need to make one hole for the USB port. A potentiometer controls the speed of the tray. Additionally, a separate switch is needed to stop the device. The switch also moves the upper section to the center position. Otherwise, the device won't fit inside the storage case. You cannot move the tray by hand. It would break the servo. But then I had a problem with the tray. The bottom surface of the part was uneven, and the sliding mechanism stopped working during testing. I had to reprint the lid in two parts to make the sliding surface smooth. I also used ABS plastic, which can handle heat in case I ever add a heater to the system. Finally, I could attach the bottom panel. I also added a rubber feet to prevent the device from sliding back and forth on the table. Here is the code I uploaded to the device. The test run looks good. The device doesn't even need full power to move the liquid properly. It can also handle the big tank without any issues. The tray stops nicely in the center when I flip the switch. I programmed a soft start and soft stop function to make the device run smoothly. The entire device fits neatly inside this box, which also serves as the etching tank. It can hold rather large PCBs up to 7 to 10 centimeters in size. The device works great, but there is one downside I didn't notice during testing. It is quite noisy, and the servo's rattling becomes annoying if you're listening it to for half an hour. But you can place it in another room and close the door. Aside from that, it works perfectly. I hope this video was helpful to you. Thanks for watching.